Hello, welcome back to ME4111. As I said, we're working through tutorial sheet 5, and we're currently on to question 7. And looking at this one, we have a 3D problem, rigid body. So we've got the steel shaft, has a mass of 480 kg, and it's suspended from a vertical cable from A. So this one has a tension T1 in it, and by 2 cables in the same plane that have a tension T2 in them, so they're symmetrical. You can see that there from the offset. And we're asked to calculate what T1 and T2 are. So our first approach here is to draw the free body diagram, and you can see my sketch of it here. So I've drawn the outline of my shape. So I see that there, that's the beam, and I've no other thing in contact with it. So instead of the cable up to A, I just showed the tension T1, so that's the force. So I've replaced that contact with a force. I have the force acting due to the mass, so M times G. And then I have the 2 tensions in the cables C to B, so T2 and T2. Okay, and I just wrote in some dimensions. Now again, with this FBD, the whole point is that you no longer look at the this thing here. You forget about that, and now you're focused on your free body diagram. Okay, so it's important that your free body diagram is neat enough to be able to follow. But it doesn't need to be a work of art. You can see I'm mediocre at art at best. So working our solution now. If you take a look at the text I have here, you can see that the solution really tumbles out quite quickly. And, you know, it's tempting to be flippant about that, but to be able to get that solution out, you need to study the free body diagram. So let's go back and see how I figured out that this is going to be trivial to do. The first thing I noticed was that I'm kind of thinking ahead to moments, and I was going to pick a place to take moments. I was thinking here, if I take a moment at this location where T2 joins in, intersect the line of actions of those 2 cables, I then have 2 forces that are in the same plane. So mg is acting in the negative z direction, and T1 is acting in the positive z direction. So if I take moments due to this, the moment is simply a one-dimensional moment. So I would have mg times 1, and that would be going in a clockwise direction, so that'd be negative. And then I'd have T1, which is going anti-clockwise, so that's positive, so T1 times 4, and that would equal 0 because there's no other forces present at that point to cause a moment about that point. And that gives me T1 out, straight out of it. So that was the first thing that I did. So I took moments about that location here, where the lines of those 2 intersect. And straight away T1 tumbles out. So again, the mindset really is that I'm looking at this to see, okay, how can I figure out, I have 2 unknowns, T1 and T2. I took a moment about here, I knock out these out of it, I'm left with that, and that next thing look, they're going in the one direction. They're not the same direction, but they're confined to the same plane. So it really becomes trivial to take moments. It becomes a 2D problem. So very, very straightforward. And then once I have T1, the easiest equation I can use is the sum of the forces. And again, if I just look at the components in the z direction, I'd have a component acting upwards due to T2 there, and also due to T2 there. So I have 2 of those, mg and T1, and they're all acting in the z direction. So that becomes quite trivial. So I got 2T2 costs 26.56 minus 480 times 9.81 plus T1 equals 0. And I have T1 already, so I substitute in and get T2 out of that. Where did I get that angle from? That's coming from the inverse tan of 1.5 over 3. So it's that angle inside there. So T2, the cosine of that angle, gives me that component, and I have two of those. So the inverse tan of 0.5 gives me 26.56. Okay, so that's where that comes from. So that solution really tumbles out pretty quick from what ostensibly looks like a very complicated problem, but it ends up being two very, very straightforward 2D solutions. So the key there really is draw your free body diagram and then just pause and have a look at it and figure out, okay, well, what am I doing with this? How am I going to get my answer out? So you plan your approach rather than just diving in and following in an algorithmic approach where you're like a robot or a machine working through something. You need to get your free body diagram, you have your governing equations, and you're thinking ahead of, okay, how am I going to plan my attack in this? How am I going to work my solution through it? Okay, that concludes that. Hope you found it of use. If you have any questions or problems, just come back to me on it.